Okay folks, we're going to commence this presentation now, and we're going to spend roughly between 25 to 35 minutes on this. It may extend a bit longer, but I'm hoping to get it done within that time frame if we can at all. There's quite a bit to go through, and it's a mixture of PowerPoint and it's a mixture of practical product presentation as well. This morning's webinar is very much about CAM. Generative manufacturing, communicating to CNC controllers, how do we do that effectively and so forth like that, and what have audits got to offer on parts of their portfolio. So just to kick things off, really, what we're really talking about here is we're talking about how we traditionally design and then how we make and use particular components. This is basically our product innovation platform. Those of you that are Inventor users will very much be in the design stage, and then would then push this out to make stage, and then how do we use that product there afterwards. So this is basically really a connected workflow. As you can see over onto to the right of the screen on the top corner, that's where most of us are in our space. We design stuff. We design a componentry, we design electrical boards, we do our 2D manufacturing working drawings, and then we share that information to the manufacturing. But over recent years, what we need to look at is we need to streamline that. And how do we communicate that effectively as well? In my own personal career and where I worked in previous positions, a lot of my time is spent on design, and then what I would do is I would either send the model to the CNC controller, and they would do up the particular program at that point. But I think now what we need to look at is we need to look at a more connected process where we design, we simulate, and we're able to, I suppose, simulate the programming around how we're going to manufacture that part. It's all about making design and make closer rather than design and then push to make. And then if you take the bigger picture, once we make and produce the product, how does that product utilize in the market demand or in the public domain thereafter? How do we monitor that? How do we, say for example, how do we look at that product in time? Do we need to set up, for example, monitor the product to see if there's reliability issues? Can we do pre-maintenance rather than reactive maintenance? Can we schedule maintenance plans around a particular product and the amount of use, like for servicing, etc.? So the bigger picture is really about just the innovation platform. How do we innovate with our product? How we design, how we make, and how we dare use afterwards. And the outer circle of this particular PowerPoint is basically just giving you that idea where we can extend our design capabilities. You can see on the use, we've got basically robot sensors, pick and place the objects, that kind of stuff, factory usage, output, all that kind of stuff is basically built in on the use side of things, and where does the product go there afterwards. While in design, we design the component, and then make, you can see with the make, you've got now the CAM capabilities. You've got the microfactory capabilities where we can actually share information effectively. If I move further on here, what we can do is we can, excuse me for a second. Okay, oops, I jumped ahead of myself there, I do apologize. I clicked the button too fast. So what we're looking at and what we're going to address this morning is essentially subtractive manufacturing capabilities. In this case, you can see obviously we've got CNC milling, okay, so in there you can see standard 2, 3 CNC milling capabilities, and you can see we can also address, for example, CNC turning. So again, we've got turning capabilities, so mill and turn capabilities directly within the Fusion 360 platform and the Inventor platform now, I might add as well. Today I'm really going to focus on the Fusion 360 platform. Again, you can see we've water jet capabilities, and the last two very much similar, plasma cutting and laser cutting capabilities. So again, I suppose they're probably the main subtractive manufacturing methods that are in place today and are currently in place today, and these are what we can address with the products going forward. Today I might add, as I said earlier on, that I'm using Fusion 360 as a product I'm going to use today. What I show you in Fusion 360 is the exact set of capabilities in Autodesk Inventor. You have the best of both worlds. You have an on-premise solution whereby you can do everything locally, PC, processing code on the PC. You can also use Fusion 360, which allows you to do the processing on the cloud. So again, a very effective tool and a nice way to complement your workflow. So you could potentially do all your design work in Inventor, and if you'd like to kind of source the machining and the generation of CNC code to Fusion 60, you can do that by using collaborative methods such as Inventor, Fusion Team, etc. So for those of you that may be familiar with milling capabilities and turning capabilities, this is a nice slide that I like to show. I like to show quite a lot. And this is about basically subtractive strategies, milling essentially. So in this case, you can say, for example, you can see we've got the 2D milling capabilities up here. And so that's basically just following a particular profile. Where we use that quite a lot is if we're inside using Inventor, and we're now using the new Inventor nesting utilities, where it allows us to basically get an assembly that's made up of sheet metal components. It will flat pattern those components and it will automatically develop out this particular profile for us, which we can then send to CAM. And you can see there's a very quick simulation there. You can see also that we have the 2.5D capabilities. So again, obviously we're taking the 2D functionality, extending it to half 2.5, which allows us to actually work on the Z directory. So you can see in the 2D we're working in the XY, 2.5 we're working both XY and the Z. On the 3D environment though, that's where it really comes into play. So in this case you can see what we're doing is we're following a 3D profile. We're following both the X, Y, and we're following in the Z direction. There's many different machining processes around this, such as adaptive clearing, parallel cutting, multi-axis flow, swarfing, etc. That will allow these machine processes are built into in order for it to enable us to do this. If we extend that on further, and this is where I suppose we really would like to see people to go, and I think the main essential requirements at the moment for a lot of our customers is 2.5 and 3D. However, though, we do also have a lot of customers that are using 5-axis simultaneous or 5-axis orientation. So again, in this case, just a quick preview here, 4-axis is basically where we can actually rotate not only the tool, but the workpiece as well. You can see in the 3 images on the top, the workpiece is stationary. In the 4-axis, what we've got is to allow us to rotate the tooling as well. Okay, so for example, we can tilt the tool piece and we can rotate the tool piece. In this case, in the 4-axis simultaneous, the next step over is the same principle as 4-axis, but in a simultaneous environment. So we can rotate and spin the tool piece, and you can see the tooling down. So again, we're using the 3D with the 4-axis rotation, and we're rotating actually the tool piece as well as the actual cutter. If you go to 5-axis, again over here, what you can see, you can now see that we can rotate, we can machine, we can rotate the piece, and we can also spin the piece. That's 3 plus 2. Okay, so that gives us a bit more flexibility, whereby we've got capabilities on all those axes. So we can utilize the 3D element, we can use the workpiece spinning, and we can use the workpiece spinning on the Z and also the workpiece spinning on the Y. Now, 5-axis simultaneous, this is where we see a lot of our customers going, and we can see that we're using the 3 plus 2 orientation in the previous slide, but in a simultaneous environment. This is probably one of the most efficient way of machining and generating components. It reduces the lead time and manufacturing time of components. So again, you can see here that we're using all axes simultaneously. So we're using the 3-axis, which is controlling the X, Y, and Z. We're also using we call the alpha and the beta axis as well simultaneously. So we can position the tool, in any shape or form around the piece. So again, we can get access to certain areas. So again, you can see very much focused towards complicated products, but maybe advanced surfacing that would require that. The 3-axis, for example, will be something maybe simpler components, not much advanced surfacing, maybe some fillets, some chamfers, some depth. That's where I see 3-axis quite a lot. The 5-axis I would see quite a lot used in the automotive aerospace industry, where a lot of surfacing is involved, a lot of non-planar faces are involved, and basically, to improve time and creating a part. So from that next point, okay, so we'll just move on. Okay, I want to focus on the make today. The purpose of this presentation is very much about how we're going to make a product. You can say we've done the design at this particular point, and we want to focus on how we're going to develop this product and how we're going to streamline that effectively and share that with our end users on the particular machine environment. In this case, you can see I'm using a PowerPoint that's basically demonstrating how Fusion 360 is able to address most of these issues here. You can see today we're going to look at the top slider to the right, at the top corner. That's primarily 3D machining. If we look at the bottom left-hand corner, you can see that is also 3D machining, but allows us to do multiple components of the same program environment. I'm actually going to show you that one live. I'm also going to show you the one on the turning live as well, and hope to be able to show you some 5-axis simulation towards the end. One area that I like to focus a bit on is, obviously, I mentioned on the previous slide, is about contour cutting or profiling or something along those lines, okay? And how we're going to do that effectively and easily. So it's come across in many requests about and questions, how do we actually profile something? How do we get something effectively out to a machine that we can actually generate and use from there on? So in this case, what I'm going to do is I'm going to just show you a quick snippet of how we do that using Fusion 360. So again, I'm going to be in the Fusion 360 environment here, and again I'm going to stress I'm using Fusion 360 today, but all this functionality I'm going to show you is also available on HSM Inventor from the machining side stuff. So in this case, what I'm going to do is I'm going to start off and talk about profiling. I'm going to look at this particular swing arm here, and I'm going to open up that directly in the Fusion environment. So the document is opened. The first thing we need to do is we need to start focusing on how we're going to look at the particular design component and what our setup will be for the profile in this particular case. So within Fusion 360, and I can just minimize, by the way, just to let everybody know, this is just basically content that's stored in the cloud. So for example, I've done my Inventor design, or I've done my design within Fusion itself, and I've stored this information up in the Fusion cloud, or the Fusion team, I should say. And within this environment, what I can do is I can source this information on any particular device from anywhere, essentially. In this case, I've opened up this swing arm, but what I want to show is that I want to show the capabilities built in on the cloud platform using Fusion 360. In this case, Fusion 360 has many different environments, including design, generative design, render, animation, simulation, and again, manufacture, which we're going to focus on today. You can see the component in the background is made up of a number of components, bodies, okay, and we combine that into one. So what I'm going to do is I'm going to focus on the manufacturing side here. So when I focus on the manufacturing environment within Fusion 360, or Inventor for that matter, you can see the information across the top, and the panel has changed. This panel introduces a number of drop-downs. You can see here from a 2D strategy point of view, you get 2D adaptive clearing, 2D pockets, face, contour edges, so forth like that, even slots. In this case, you have also in the 3D information, you have adaptive clearing and more functionality in here, which allows you to actually utilize 3D and 3D adaptive clearing process for more complicated componentry. We obviously have the drilling and hole recognition, but the big thing for me is the multi-axis as well. Being able to have the facility to be able to build on a 5-axis simultaneous environment within Fusion 360 is a very powerful tool to have, and allows end users that natively would be using a design componentry inventor that bit of freedom and flexibility to actually look at the manufacturing cycle as well. And alternatively, maybe look at modifying the part to suit the manufacturing process downstream. There's one thing we'd like to kind of share with you today is the fact that we want to kind of be able to say to you that you have that flexibility, you have that freedom to explore that option, rather than just designing a component, sending it to the CNC machine, and then realize maybe this is not the best strategy to go with. Maybe we can improve the part or remove a pocket or make a pocket smaller, or maybe there's been certain cases in my experience where I've actually sent the part and find out that there's been a tool collision because the tool actually can't get down to a certain pocket or to a certain area. So I suppose with this capabilities and to extend your capabilities within the PDMC, it's very much focusing on the designer being able to simulate that manufacturing process before it actually is manufactured. It's all about our digital and our digital product information platform, how we can innovate, how we can effectively do our design right through to manufacture going forward. In this case, the first thing you would normally do when you're setting up an environment is you just create a setup. And a setup is essentially to kind of give an area or a focus or an origin point or a data point onto where we need to relate to in order to generate the NC code. In this case, all I'm really doing is I'm specifying that I've got this model orientation, and what I'm really doing is I'm going to come along here and I'm going to specify the stock point, the point where I'm going to use, and where I'm going to set up the origin point for this particular profile. You can see always as indicated, and those of your Inventor users will recognize this, that the X is in the red, the Y is in the green, and the Z is in the blue. So once we've established that, now what we can do is we can start looking at, right, what do I want to do? What's the machine process I'd like to do in this case? For example, I'm going to select 2D profile cutting, which is what I want to do. In this case, you can see what we can do, and this is very, very important to realize that within Fusion 360, we have a tool library, and this goes again for Inventor, I should say. It's a common tool library that we're able to select from a tooling library that's already available to us. So for example, if I select the water jet in this case, which I want to use a water jet processing in this case, what I want to do then is I want to now select the profile I want to work with. In this case, what I do is I come along and I select the geometry. And all I'm really doing in this case is just orientating the part. And you can see here, I'm just going to rotate the part around. I'm going to grab the profile I want to work with. And you can see, I want to select this profile here. I want to select the outermost profile. I want to include as much information I can within the actual current profile. So again, I might select this internal loop. I'll come along and I will select all these other slots here as well. So these little pockets that I want to take out, not really pockets, but they're basically cut out to the part that we want to. And again, anything that I feel that doesn't require a bore or additional machining or additional process, I would consider to include in the actual 2D profiling that I have here. So if I go back into the orientation, you can see what I've selected. So what I can now do is I can select OK to that. And you can see it's going to generate a quick profile for me. And from there then, we can actually kind of get an idea of what we're going to simulate here. So in this case, using the environment that we have directly inside in Fusion 360, what I can now do is I can simulate how that tool would work within the environment. And I'm also going to show on the stock as well, to kind of give you an idea of how this works. So in this case, you can very quickly come along, I can speed up the simulation, and you can see it follows the tool path around and gives us the information that we currently need. From here, we can do many reports, and I'm going to continue this on when I start going into other more tricky environments as we go along here and more advanced kind of information. What we can do is you can see the tool path, you can see the information, we can speed this through until we close it out. You can see we've got the setup sheet that's available to us here. So again, you can see I'll just come across here, select the folder, and I'll just call this, okay, we'll call it that, okay. And that will give us a setup sheet, time, the area that's covered, the tool path, the distance of the tool path, for example, etc. as well. So this will kind of give us an idea, firstly, a first round idea as to kind of, we can actually come back to this at some point and actually either increase or change the tooling, change the cycle, etc., etc. So there's a lot there to consider, and that's just one of the areas, and that's basically just 2D profiling. To move on from this, basically what I'm going to do is I'm going to just jump back into my PowerPoint. Sorry, excuse me. There we go. Okay. And what I'm going to do next is I'm going to talk about basically our 3D milling capabilities. Okay. So in this case, I just want to highlight on this screen, you can see there's a nice image showing of a component that's actually clamped down and so forth like that, positioned correctly, and you can see there's a lot of tool paths going on there at the minute, okay? Obviously those represent different kind of machining strategies, number one, so you can see over to the left-hand side on the model browser, or actually the browser within Fusion, you can see that there's a face one, there's adaptive, and there's 2D adaptive, and there's bore. As you can see, these are all particular machining strategies applied to this particular part. The initial step with anything that we set up within CAM is we set up the initial setup. We set up our tooling, we set up where we use a vice, or we use clamps, and we indicate to the software this is what we want to use. But the reason being that is because we want to determine if there's going to be any collision with particular tooling along this particular machining process. There's also, you've got to realize as well, there's multiple machining processes. This could be one process, but there might be an underside process this part as well. And how do we cater for that? So there's a bit more to it, but it's kind of getting the end designer kind of used to the idea of what's the ultimate goal here, how we're actually going to manufacture the end game here, or the end part essentially. This is what I meant about multiple processes or multiple definitions, or using multiple parts or multiple machine strategies on a particular component. You can see in this case what we got is we got this particular component on the top side. This is basically a car hub used for a particular racing cart. You can see there's the top part to the right, the lower right of the screen, and then we've got the underside of that part on the upper left of the screen. So what I'm going to do now is I'm actually going to bring you through that. I'm going to actually walk you through the stages of applying I suppose there are machining strategies towards something like this, how we would initially set it up, or how do we work with the stock, what do we select, that kind of stuff. So without further ado, I'm just going to jump into that. So So I'm going to jump into, excuse me, I keep talking this, so that's my bad. What I'm going to do is I'm just going to close down the initial one, and the reason why I like to open up these fresh is just to kind of show you, excuse me for a second. I'm going to just get out of there. This is just to show you that I'm actually opening up, I'm using just broadband connectivity here, and I'm loading up the components as such. I'm just going to do a very quick update, make sure I have the latest components available to me. And what I'm going to do is I'm going to come along here and I'm going to zoom out to see the local area like this. So you can see that we've got this particular component here, and I'm just going to maximize my screen, my model screen environment. I'm going to maximize my Fusion environment here as well. So you can see that what I've got is I've got those two components in place. And the first thing we need to establish is our, number one, our stock. What are limits, what are machine boundaries, etc. with this particular component. And that's pretty easy to find, to be fair. Again, using my environment tab down here, I'm just going to move over to the manufacturing environment. Within the manufacturing environment, the first thing that we need to do is, again, do a quick setup. And the setup is, again, to establish what are we actually machining. So we're setting up our stock. We're setting up the type of model we're going to use. In this case, I'm going to select the model, which is going to be this here. And this is the model we're going to use. I'm going to specify the orientation of how I'm going to machine this particular part. Again, looking at the data point. I'm going to specify that we got a Z-axis, a plane axis. I'm going to specify the reference to give the orientation on my Z-axis. I'm going to give a stock point on here, which allows me to put in the data reference point for our first position or two. In this case, once I have that set up, I can click OK. You can also indicate if you have this particular type of fixture. In this case, I've indicated that I'm just going to use the model stock. I'm going to indicate where the start point will be, which has been effectively around the part. Now I'm going to start looking at the machining strategies. How are we going to start this off? First thing we're going to do is we're going to look at the adaptive clearing for a 3D environment. If you look at the adaptive clearing, this is very much used for roughing out and getting the bare bones of the part machined initially. Okay? A good thing about adaptive clearing is the fact that what we can do very quickly and easy, it kind of gives the boundary of the part, it works with the part, lets us give a good start, and it's the first initial process. So again, I'm going to start off with adaptive clearing. Like anything in this case, what we really need to do is we need to select the correct tooling for this particular machine strategy. In this case, what I'm going to do is I'm going to come along here and I'm going to select, again from the tooling library, the tooling that I want to use. In this case, I'm going to specify that it's going to be a round bull nose tool with a slight radial fillet end on the tool as well. So in this case, once I've selected the tooling, the next thing I need to establish is, and it's very important, is to establish where you are going to come, your heights and your levels and where your endpoint is and how far do you need to go into the particular part. So this is pretty much established here. As you can see, you've got the bottom, you've got the clearance, you've got the retract height and the top of the part. So these are all important, and this is what happens when you select the model. It actually calculates some of this information, so it knows the retract levels. It will know the bottom level of the part. But as you can see in this particular case, what we're dealing with is we've got a collision, a possible collision here because we've got this particular vice in place as well. Now we can set that up that we can avoid the vice like that. But in this case, I'm just going to kind of show you how quickly and easy it is to modify. If I grab something like this, you can see I can drag and drop. I can even input a dynamic value in here, and I can set that in place. Once I've applied that, you can see what's going to happen now. It's actually coming along and it's generating the tool path for that particular part. So it just takes a minute or two to get through. You can see I'm currently at 70%. And you can see very, very quickly how it's actually found the information of the part, got the contours of the part, and got it up and running. You note that I have an error. And in the error in this case, you can see I'm getting a warning like so. So that's a warning. So in this case, what I can do is I can click on the warning and it says, well, there's a warning here, rest material adjustment reduced to maximum limit. So basically what I've done is I've inadvertently left rest on in the actual particular operation. So in this case, what I'm going to do, I'm just going to come along here and I'm just going to explain what rest is. If I come along, so rest machining is basically a process following another. So for example, if I had done some a process before this, then this rest machining would allow us to take that process into consideration for the next process. So it's like a follow-on, like a chain effect. As we don't have any machining process before this, I'm just going to turn this off so it doesn't need to be calculated. And now what we can do is come along and recalculate the actual information again. So in this case, it's redeveloping the tool path and rebuilding up the tool path for us as such. Now, once we have that done, what I'm then able to do is I'm able to come along and simulate that in its form. So again, using this, what we can do is we can do a quick simulation. I'm going to leave the stock on just to kind of give you an idea. And what I'm going to do is I'm going to try and speed this up to kind of give you an idea. So again, you can see with this machining process, I'm just going to zoom in a small bit just to kind of give you an idea. You can see very quickly we can get the groundwork done on this particular part and very effectively as well. Now again, there's a lot more to consider here, but this is the initial machining process that we have in place. So you can see we're getting the bare bones of the parts, we're putting in the certain pockets that we need to remove, and we're building up the particular components in here. Okay? There's one thing, however, that I'm not forgetting to doing, and I think it's a nice way to show this as well, is that I'd like to show how we face off a part before we actually tuck into the actual bare bones machining. There is spaces that we need to preserve in this part as well. So in this case, what I'm going to do, I'm going to come along and I'm going to do a very simple machining process called 2D face. Again, I can select the tooling from the library that's built in, and I can specify I want to do kind of 2-inch face now. The reason why I want to do that is I want to pick on this particular face in here. So if I just click OK to that, now what we're doing is we're putting in a face operation as well. But the sequence of events is not entirely correct here. What I would like to do is I would like to reorganize my machine strategies a bit better. So what I can do is I can simply drag and drop the face information, pull up before, and I can change the sequence of machining operations effectively here. Now if I run the simulation, however, it's a bit different. So if I simulate this, now what I can do is I can come along and I can specify, I can do my face mill first, then I can do my machine strategy and move along. And you can see we have a much better effect on what's going on here in this particular part. Now, I'm just going to, as you've seen that simulation part already, I'm going to add another machine process to this as well. We've actually roughed this out, we've shown the tool path, and actually what I might do is I might just turn off the tool path for you guys the next time so that you can see more effectively what the part is actually doing and how we're machining this. Now as you can see, we're speeding through this pretty quickly and we've done quite a lot of work. What I'm now going to do is I'm going to come along here and I'm going to actually tidy this up a small bit. We're going to add, as we roughed out a lot of it, what we really need to do is we need to start smoothing off these particular edges as well. So now what I'm going to do is I'm going to add another machine process to this. So what I can do is I can create a derived operation which allows me to basically do what I did with the rest of machining. It allows me to jump from one operation to another very quickly, effectively, and lead on with the same tooling. In this case, I'm going to specify that we're going to select parallel. Again, I'm going to specify a particular tool for this particular operation. And in this case, I'm going to specify a 1/4 inch ball. This allows us to actually do a nice, more finishing parts. We roughed it, and now we're going to apply the finishing surface into it. Okay. So again, this is kind of bringing it to the next level. All right. Whereby now what I can do is I've selected tooling. Now I want to select where am I going? What's my boundary for this particular finish? In this case, I'm going to specify that I'm going to selection here. I'm going to grab this. The finishing areas that I want to focus on is any particular hole information I want to work on here. And you can see here as well. Okay, and any particular information that I want to kind of finish off, I can do directly here. So again, I'm just selecting the information. Now, I have also, just to speed it up, I was going to show why we select this, but I want to include these pockets, but I want to include this on the initial one. So I'm going to grab this. I'm going to grab these. Now, basically what I'm trying to do here is I want to finish the inner walls, top walls, the inner walls of these particular pockets as well, to the depth that I've specified. So again, in this case, I'm going to grab here, and I can deselect it. There we go. And I can grab. So it's very quick, easy to pick, place. I'm also going to set that we're going to, well, I'm going to run the simulation first if you don't mind. I'm going to just to show you. And if I click OK to that, now what we got is we got this particular parallel computing going on here. So you can see we've got this particular two path started up. So this allows us to pick this information across here. So if I now come along and simulate this again, our face operation, our 3D adaptive operation, okay, and we can now move on and we can specify this particular operation here as well. So now what we can do, you can see it's going to come along, finish out that 3D adaptive, and we're going to move on to the parallel tooling, which allows us to kind of put a bit of a finish on this particular component, okay? So we'll just speed that through a small bit more. So now you can see that we're kind of getting the finishing edges on this particular part. But my problem is it's very kind of rough and ready, and this is about our passes, our gaps between the two paths itself. If I go back into the two paths, you can see here very quickly, you can see all these lines here there's quite a distance between those, and we're not getting the associate finish that we do require. So this allows us, again, going back in, we can edit, we can go into our passes, we can specify the gap distance between those passes, and then, for example, I'm going to do 0.02 of a pass on this. It's going to take that longer to simulate and generate, but you can see we got a much more defined toolpath, a much more finished toolpath here. The one thing I also want to add to it is I also want to be able to come along here and avoid certain faces as well. Because remember, we face this. Now what I want to do is I want to make sure that I avoid this surface here and that we just have a face finish on it from the first operation. In this case, I've simulated, I've run it. I can also determine if I want to avoid the internal face here as well if I wish. But for now, what we'll do is we'll just run the simulation on this. And this will be our complete simulation. And we'll just speed this right through as you've seen this already. And you can see very, very quickly, we built up the operation and we've confirmed that we want this operations in place. We've validated the toolpaths, and now what we're doing is we're speeding up the rest of this particular end, and we're going to use the parallel. Just move this slide out box out of the way so you can see a bit better. There we go. Now, the big thing about all this really is that once I have this particular tooling information done, what I want to do is I want to be able to reuse this particular information here again. I don't need to set up all these processes again if I have an operation on the underside of this part and I want to be able to reapply these particular operations without going through the necessary setup again. So as I have these three processes here, machine strategies here, all I really need to do now is I need to copy these and I can say store these as a template. So I want to call this, okay, and I'm going to save that out. I'm going to replace the one I had from previous, and I've saved that template there already. Now I want to come across and I want to be able to create a new setup for the underside of this part. And this is very effective as well, because what we can do is create a quick setup, specify again the part that we're going to use. In this case, we're going to specify the model. We're going to specify the model orientation. So again, I can specify the orientation. I'm going to specify the box point, which is this box point here, and then now I'm ready to go. In this case, once I select OK from that, you can see straight up I have the setup already done. But what I really want to do is I want to come along here and I want to be able to create from a template. In this case, I'm going to grab the template I already built. You can see I've got these particular processes again. You can see they're abbreviated by 2. And what I can now do is I can come along here and I can say, for example, I'm just going to come along here and I'm going to edit this particular toolpath here. I have the tool information. I just want to confirm on the collision detection. I want to confirm on the bottom part. I want to confirm where it's machine and process. So, for example, I want to put that to 0.8 so that we got the bottom height of the model established, so we know that our clearance, our top part of the model is defined, and our clearance heights and our retract heights are all set up ready to go. That's the first part. I'm also going to look at the parallel one as well, and again I'm going to do the same thing. Make sure that all my passes are correct, because it is a derived, so it's taken some of the information from the previous, and we want to make sure that that retractable height is set up, bottom height set up, and now you can see very quickly that we've got those particular processes actually calculated and already done for us. And again, what I can do is I can come along here and I can regenerate the face one just to make sure everything is okay, and rerun the simulation on the underside. So again, let's come along and simulate this particular section and speed this right through. So again, now we're working on the opposite side of the part. You can see how quickly and effectively that is, how we can apply other machine processes to this very quickly and easily, and how we can build on this there afterwards. So now you can see all that, and you can very quickly see here as well by the 2 bar at the bottom which parts of the process we're currently active on. So again, moving forward, okay, and then we got a parallel bit now being built in there as well. I should turn the toolpath off. There we go, and you can see this is much more easier to see now at this particular point. Okay, so you can see how quickly and easily we are able to build up these parts. Now I'm speeding through the simulation, folks, and I do apologize for that, and the reason for that is so that we can kind of move forward with the next 2 bits that I have, okay? And I'm going on to 2 remaining bits. One is turning, and just one to show an example of 5-axis and a 5-axis setup, okay? And then that should open up the session for questions and answers if you wish. But let's take it on to the next step. Before I move on here, one thing I'd like to show is obviously the setup sheet again. So you can see I can specify a setup sheet here, which allows us to set up for this particular process. So you can see the stock, part sizes, number of operations, the number of tooling, the type of tooling we're using, the operation time for that tool, etc. as well. So this is kind of a nice way to look. Also what I can look at as well, and just to kind of see the post-process. How do we run with the particular post-process? What do we select? So again, in this particular information, you've got all these machining providers available to you and their post-process set up. Please bear in mind, these are templated post-process. They will need to be edited as per your machining requirements in-house, but there is a stock of those available to you at any stage, and you can utilize those, and you can edit those if you're comfortable with editing a post-process for machine. We've done slight editing in post-process here, especially on the 3-axis stuff, but the 5-axis stuff, you may need someone to do that for you, because that's quite detailed. So if I particular machining process, if I select the post and I want to get the NC code, for example, and I want to say this is going to be, and I go save, that will generate up the code for me and give us the code details straight off here, which we can then export out. And you can see in this case there's over 84,000 lines of code, so there's quite a lot in it. Okay, so you can see very quickly we've got this information set up and working. So now what I can do from there, so between the setup sheet and the NC code, we can deliver quite a lot. The last bit I want to discuss is basic around turning. So in this case, very quickly, I'm going to come along here, I'm going to open up a turning part, and just kind of quickly go through just a turning, very simple turning part, because again we're running out of time here. What I really want to do is I want to kind of, again, the same process. We go into manufacture, quick setup. We come along to the stock. We specify what we want in the stock. So we specify from a solid. We specify the solids that we want to work with. So again, in this case, I want to pick on this particular solid body here. And you can see very quickly, I can specify the profile, the setup, and it's not a milling operation, it's a turning or a mill turn operation. And you can see here, I can set that up very quickly. So in this case, what I can now do is I can come along here and I can look at this information here. And what I want to do is I want to come along here and I want to specify 2D pocket. So in a 2D pocket, actually what I might do, folks, if you don't mind, I might change that back because I want to show a little trick. Okay, so in this case, so what I want to do is I want to start doing this in a 2D pocket in here. So for example, if I select 2D pocket, what I can now do is I can come along and I can select a profile that's more suitable for that 2D pocket. So you can see I can select this profile. However, I want to wrap this to the toolpath, so I want to select this particular surface. So I want to wrap the profile around the part. In this case, what I want to do is I want to come along here and I want to select the profile again. I want to select the icon, I want to select, well, this is the correct profile. I want to be able to establish the profile path that I want to use. So in this case, you can see, now I've got everything set up. This is the path I want to use, the tool set up, and now I want to click OK to accept that. And you can see now you got a machine process that's already defined the path right there. So now we can start doing the milling operation in a 2D pocket here where we can specify this particular information here. Now, the last thing I want to do is I want to use a multi-axis and I want to use a swarf. The swarf basically allows me to have a nice finish on these particular contours here that we would have. So if I select something like this, I can specify the contour and I can specify where I want it to go. If I select OK to that, you can see now we've got the path ready for the contour. So let's come along and quickly simulate that and kind of show you how this operates. Okay, so again, you can see, we'll just speed this up. There you can see, obviously boring to the part, taking the information around the part and removing that pocket at a steady pace. So we'll speed that through. You can see that we're speeding through and we've got our contour in place like so. That's the first part of our pocket information, spark information. But remember, we have a number of pockets here that need to be addressed as well. So what we can really do very quickly is again grab, very much like we did in the previous example, grab, add to a new pattern, specify that it's going to be a circular pattern. We can then specify the axis. So again in this case, so we can specify the axis here. So we can specify this axis. We can specify how many do we need, which is going to be 3 in this case. And you can see by the preview, we've automatically got these previews set up and it's taking both operations at the same time. So now that I've done it on one pocket, I replicate that across the 3. Finally, something like this is very important as well, where we should be able to contour machines like this on a particular turn part. And again, in this case, what we can do is we can come along here and specify again a 2D contour. We can specify that the contour that we want to take is this particular contour here. And again, you can see I'm following this path here, following down across the component. And basically what I want to do is I want to be able to wrap that to the part as well, like so. If I click OK to that, that's the contour I want to take. Okay, so we can see how that develops, how that works around. So you can see how we can take apart like that. And what we can do is very quickly, we'll just do a quick simulation on that just to see what that looks like. And we can see we can develop that up. You can see it's taking the part information around, it's taking the component that we need to keep, and so forth like that. We can even change the profile as well, and you can see it's going to come along here like that. So again, in actual fact, that's the wrong profile. So again, I'm going to do that very quickly. And you can see I'm going to select the contour slightly different this time around. And I grab this one. Okay, and we can take this one, okay, and we'll say we'll wrap that toolpath that we need. Okay, we can even add to this, so we can take away things from this. We can even come along here and I can say, well, I'm going to click on this now, and I can say, well, I want this as well, and I click OK to that. So again, what we end up now is building up the 2D contour for both sides, and you can see we end up with a profile like so. So very easily, what I can do is I can come along and I can simulate this as well. So now, before I jump the gun here, let's very quickly go into the entire setup and simulate the entire process here and move this on pretty quick. So there you have it. You have the first pocket, you have the multi-axis swarf for the face. So that basically the swarf allows us for the side part of the tool to be used across the walls to give us a better finish. Then you have the profile on the top. And the key to all this, obviously, is the NC code, and secondly, the setup of that particular file as well. So, for example, I can set the setup, and again, I come along to this particular folder, and we can get the setup sheet, and you can see again the tooling operations there, and how and what are we using to get that tooling. Last but not least, and again, I'm aware I'm out of time, and I'm just going to check our chat. Okay, perfect. So I'm just going to check if there's any questions on the chat dialog box. The last thing I want to show today is very much about the 5-axis and the 5-axis simultaneous workpiece. So again, I'm just going to open up something very quickly. I'm not going to go through each machine strategy on this. What I am going to do is I'm just going to show you, like this is a stock that's around this particular component. You can see that there's fillets, there's curvature involved, we're facing, and so forth like that. But you can see the build-up of this particular one. You've got adapt clearing number 1. You've got patterning of that adapt clearing, because we're going to take care of these face elements here. Again, you want to pattern that particular component and the machine processing of this particular component. You want to circuit pattern the bore, okay? And then you want to swarf off the edges for the final finish. So again, very quickly, what we'll do is we'll simulate through this. And I'm just going to make this a bit, just to kind of hope that you kind of get a better feel for this. You can see the machine strategy. It's like very much like a polygon that we're trying to do, with like an 8-sided polygon that we're trying to machine here. So you can see the tool is targeting itself to make sure that it meets all that area and that area and the corners, and you can see it's stepping that as well. We can even control the steps, the step sizes, the finishing, the roughing, how smooth we want to finish it out, if necessary for you to polish as well. So in this case, you can see we're still in the adaptive process over here, and this should move on pretty quick in a second. So we're removing a lot of the heavy information, the heavy material. So this is kind of our roughing phase. And then what we can do is we can come along here, and you can see we can speed this up a small bit. So we're just moving along and getting into the parts that we need to be concerned with. And now we're going to start moving on to the next machining process. So again, you can see the roughing is pretty quick. Let's go. And now we're going to the internal bore. From there, then we're going to start working on the face side of things, where we're going to start smoothing off the outer faces. There we go. Okay, good. And then the internal bore, we're going to do the internal bore still. Let's go. Okay, and now you're at the element where we're now machining off and facing this off. Okay, so again, you can see that's the strategy, and you can see over to the right or to the left in the browser, you can see where we are in the toolpath again. So the setup sheet is quite effective. Now we're doing the flow. The flow operation is very much where we can tilt the tool to get into a particular area or a particular defined area. You can see in this particular face, it's angle number 1. Secondly, we have a lot of fillet work and surface work, and this kind of groove work in there. So this is where our flow processes work quite effectively. And again, we're repeating the steps. And you can see this is all about the patterning, so you can see it's going to repeat the step again. So we can do it on one, a pattern around that particular symmetric component. We'll speed this up a slight bit for you, and you can see the two tilt. So this strategy will be used either the 3+2 or on the 5-axis simultaneous. 5-axis simultaneous is probably where it will be used more effectively, to be fair. But you can see very quickly, we're building up the components. And I'm just going to speed this through a bit further, folks, just to, there you go. Okay. So it's going to finish out that, and then finally what we've got to do is we've got to do the boards. So again, there's a nice bit of work in this part. There's quite a lot in it, quite a lot of strategy and setup and machine setup in it. But this is something that I hope that you got some detail from this morning, and it's more informative about the CAM capabilities from the PD&C toolkit that we have with us. I'm just going to close out my presentation at this point. So again, what I'm going to do is I'm going to move on. So I've covered really the turning, I've covered the turning element. What I'm going to do is, you can see just as a summary, we kind of covered machine strategy on the top left-hand or top right-hand corner, pattern components, and you multiple machine processes and components in the same worksheet as work setups, turning information. I've very much presented Fusion 360 this morning, but I will reiterate, everything I've shown you this morning is also in Autodesk Inventor. So you have the best of both worlds. I just like using Fusion 360 to show you the flexibility it has, and then complement your workflow with Inventor. It will free up your Inventor resource to use Fusion 360 for your machining process and to share fetch with other users as well. If you want to find out more about Fusion 360 and its capabilities, CAM capabilities, you can go to Fusion 360 or Autodesk.com Fusion. But also feel free to contact the technical team here. Our colleague Mark Foley, our manufacturing technical sales specialist, will be in contact with you or will follow up on after this presentation if you'd like to find out more information from myself or from Sid, our manufacturing technical specialist, and Mark, obviously, as our manufacturing sales specialist. So you can contact either any member of the team if you'd like to find out more, maybe get some information on the presentation we did this morning, or if you have any further questions and you don't want to go through the questions here this morning, and you don't want to go through the questions here this morning or ask questions now, feel free to contact us after this presentation. We'd be delighted to hear from you. Finally, I would like to say, if there's no questions, or I suppose before we close out the meeting, does anybody want to ask a question at this particular point? Or would anyone like to input something into the chat dialog box before we close out this meeting? Not as of yet. Okay. I think what we'll do with this particular point, we will close out the presentation. I would like to thank you as part of the ProKit team and myself that for taking the time out this morning to attend this presentation. This is, I suppose, completion of our 3 series that we've done in relation to, we started off with Fusion Team and collaboration with Inventor and Fusion Team and collaboration to the wider audience and outside of the design office, to our second webinar, which is very much about Nastran simulation capabilities and extending your simulation capabilities with the PD&C portfolio using Autodesk Nastran and not just Inventor FEA. And then thirdly, I suppose this webinar is all about the CAM capabilities, what machining capabilities you have and how we can share those and I suppose simulate those manufacturing processes before we actually go to manufacture as well. So giving the capabilities to test your design work and make that particular product there afterwards. Another thing I'd like to note as well, we have a few more webinars coming up, and one in specific is about data management, how we're going to share with BIM 360 and Fusion 360 going forward, and how we do that collaborative effort as well. So how do we share from the design office effectively in the BIM 360 world using Vault and Vault capability tools? And that's coming up on the 23rd of October. If you have any queries at all or anything that you would like to discuss for, please feel free to contact the team, as I said. We will pass on the contact details of the follow-up email here, both mine, Sid, and Mark, and we'll be delighted from here from you. Without further ado, I will close off the presentation. I would like to thank you for your time this morning again, and it was nice presenting to you, and I hope you found it beneficial. Chat soon. Take care.